Hello, my name is Bernhard Siedler and I got the honor to introduce the next generation Active PFC of ebm-papst to you. Right up front I will start with a spoiler, and everybody of you who is already using our today's Active PFC can more or less shut down at this point, because the new one does what the old one did. The only difference is it's a bit stronger. And a few features we came up with after all, but more about this later on. Before I now will explain to you what is so nice about the Active PFC today, we will have a question. Why? Why should anybody use an Active PFC? And in order to answer that, we should have a look at today's application that we can't think of anymore without. For example, LED lighting, the charger of a smartphone, variable speed drives, the EC motor technology, or heat pumps that are regulated, as well as home entertainment systems. All of these have one thing in common. From a beautiful voltage like this, they will draw a current that is more or less looking like something like this. And it shouldn't be a problem from an optical perspective, but a wise man in the past, called Fourier, he found out that a current form like this also contains the so-called harmonics. So, for example, the 50 Hertz frequency in Europe will mean multiple of 50 Hertz in the supply grid with different amplitudes. Looking at the frequency spectrum, we can see that besides the 100% base frequency, we will also transduce all these harmonics along the power lines. And we can calculate a so-called THDI, and the formula for this can be seen up here. Now, all of this sounds very complex, and the reason for that is simply because it is quite complex. Luckily for us, we have the Active PFC, and out of a nice voltage, it will also create a nice, almost perfect sinusoidal waveform current. Due to that fact, we can almost forget all about the complex stuff down here. In order to see how good the Active PFC actually is, we will have a look at the next slide. And you can see on the left-hand side the THDI on the axis. On the right-hand side, you can see the power factor. And down there, you can see the power consumption in percentage. The red dotted line here, it represents the 5% margin, which is in many specifications, for example, for data centers for THDI. As you can see, at full load, the Active PFC has a very low THDI, and even down in the partial load range, it will stay below the 5% margin. Just to give you a feeling what it means, to compare it with today's EC motors or market standard variable speed drives, they are ranging in about 30 to 40% THDI. So when you have the axis over here, you would have to double it, and still the values would be above that at full speed. Not even talking about partial load, where it would be even worse. Now, these numbers are quite impressive, I know, but what is the actual benefit for the customer? To answer that, I prepared this slide. We have a given data center with some heat load, which needs to be cooled by a few fans, in this case 220 conventional fans, and the according power supply infrastructure. When we exchange these fans for Active PFC fans, then we can save something over here. For example, the switching system can be dimensioned smaller. The transformer supplying the installation can also be smaller. And also the backup generators will be smaller. Also the cable, you know it, they will be smaller. Since we have a lot of small components now, we also need less space to deploy all of these components. And less space means either less rental costs or more space for the data center to be deployed. With all of that, we can have a savings of about 38% compared to the conventional setup. Now, if you are interested in the background for this calculation and the reasons for the savings, you can either write down this link that I put down there below, or you just go to your favorite search engine and enter white paper, Active PFC and ebm-papst, and you will come to the same page where you can download the white paper for free. Now, with all these benefits, we should have a look at the special installation requirements that are necessary if we want to use an Active PFC compared to a standard EC fan. And they are, actually there are none. That's it. So there is no extra cabling on site. You don't have to do measurements to check if you reach the targeted values, and you don't have to adjust the installation to site-specific conditions. So as blank as this sheet is behind me, as important is it, in my opinion, because all of this is a real benefit for the customer. You don't have delay, you don't need to delay the project because of some measurements and so on, and that's a real benefit. However, at this point I have to make a confession, because everything I told you so far is an old hat. Today's Active PFC basically does everything of that. So it's time now to look at the new Active PFC and see what it can give you in additional benefits. First things first, the 4 kilowatt. That's what I already promised. We get more power out of the new electronics. That was a demand by the market and we listened to the market, so we increased the power to 4 kilowatts. The rest of the benefits mostly is already known from our Generation 3 products of other lines. And you can see the reinforced electronics for worldwide deployability, the replaceable electronics in the field in case it should be necessary, and also the vibration sensor, which is already on board, which means if you want to avoid resonances on site, you can do that without additional equipment. And the new Modbus version, it has so many features, I can't even list them here, it would just be too much. And the programmable interface, that is already known from other products. Now, when we look at the most important, the 4 kilowatts, and we see on this, to check what it means aerodynamically, we can do the fan curve comparison. The blue curve shows today's ReadyPack Generation 2 with the Active PFC of Generation 2. The orange curve represents the same impeller, however, with the stronger electronics. And you can see the envelope that we can reach is a lot bigger. So if that isn't sufficient enough, then you can change to the new generation ReadyPack and combine it with the new generation Active PFC, and then the envelope will be even bigger. With all those positive aspects in mind, there's one final question to answer, and this is when will it be available? So let's have a look at the timeline. In the past, we used to have the EC Generation 2 technology in the market, which is still available, but is slowly phasing out. Back then, the only chance to reduce harmonic distortion was to use external filters. No matter if they were passive or active, both of them had one downside, and that means extra installation effort. No matter if cabling or measuring and so on. In 2017, ebm-papst pioneered and introduced the integrated 3-phase Active PFC into the motor. And since it was such a success on the market with thousands of units sold to the field, it's only logical to go ahead with the Generation 3 version. The start of production is planned for February 2022, and if you can't wait that long, or if you want to check if I may have promised a bit too much, then you can contact us and order your samples on October 2021 already. I hope I could raise your interest for this technology, and maybe we'll see in the future during one of your projects with ebm-papst 3-phase Active PFC. If you enjoyed this video, please don't forget to subscribe and have a nice day.